All right, hey there, ladies and gentlemen. Today we're gonna start looking at something new. We're gonna look at square roots and squares. Let's start with squares. Up here at the top, if you notice, we have a 3 with a little 2 up top. This is what we call squaring a number. The 3 is called the base, while the 2 is actually our exponent. So these are important vocabulary words that we're going to be using. And the cool thing here is it's kind of a short way of writing something special. So we're going to, the exponent tells us how many times to use the base as a factor. In other words, this one means 3 times 3. They tell us how many times to multiply the base times itself. So if it was like 3 to the 4th power, that would be 3 times 3 times 3, and so on and so forth. 3 squared is read, or 3 with the little 2 is read as 3 to the 2nd power, or, as I just said, 3 squared. So as we look at this first one, we have a square that has a side length of 3. Remember, anytime we're looking for a side length or the area of a square, that would be 3 times 3, right? Which means essentially there are 3 columns and 3 rows. So if this is the side length of 3, what we're doing here is multiplying 3 times 3. So in this case, 3 times 3, or in any case, I guess, 3 times 3 is 9. So 3 times 3, which means 3 squared, that equals 9. So we could do the same thing with the next square. We're looking at a square that has a side length of 5. So again, we're looking at 5 rows and 5 columns. It doesn't need to be perfect, you guys. So when we have 5 rows and 5 columns, we're looking at an area of 25. So let's simplify this. 5 times 5 equals 5 squared, which has a value of 25. So if we're looking at any square, an area of that square will likely be the middle. So like, what space does it take up? And then of course, this would be our side length. So in order to find the area, we would be taking care of side squared. All right, now let's take a second and look at square roots, the opposite of that, or the inverse operation of that. So square roots or the square root tells us where a square came from. So they tell us what number was multiplied by itself 2 times to get the square. So in other words, we're looking for the side length. Kind of reverses it. So when we squared the number, we were finding the area. Now we're going to have the area and find the side length. So for example here, we have 16 as our area. So this is our area. What I want to know is, what is the side length? So in order to find this, we're going to use the square root. So the square root is this funky little symbol here. So we're going to take the square root of 16. And we can do that by using Desmos. I'm going to see if it'll let me here. So square root of 16 is 4. So now I'm going to use that to my advantage. So I know that essentially I'm taking 4 squared, right, which is 16. And all I need from that is the base, which is 4. So our side lengths are 4 and 4. Let's try the next one. This one is incorrect. Let's change this 20 to a 36. So of course, 36 is our area. So I'm going to take the square root of 36. What number times itself will give you 36? We just did 4 times 4 is 16, so it has to be bigger than 4. 5 times 5 is 25. How about 6 times 6? So the square root of 6 squared which would be just 6. So that means our side lengths are 6 and 6. All right, this last one, 25. Square root of 25 would give us our side length. You can use Desmos, or this is what we call a perfect square. So this would be the square root of 5 squared, which is 5. So again, our side lengths here are 5 and 5. So to kind of recap what we just looked at, inside would be the area, as always. But to find the side length, we're going to square root that area. So when we talk about squaring a number and the square root of a number, these are what we call inverse operations. They undo each other. So if we look at this closely, if I square 3, so 3 times 3 is 9. So if I look at it this way, the square root of 3 squared would be like saying the square root of 9. And that base is what we're looking for. So this would be 3. So the square root of 9 equals 3, because that is the base that's being multiplied times itself twice. And the last but not least, how do you find the side length? We just looked at that here. You square root the area. Today we've talked only about what we call perfect squares. This is where you take a value that is rational and multiply it times itself. So for example, 1 squared would be 1, 2 squared, 4, 3 squared, 9, and so on. We can continue this pattern. These are all what we call perfect squares. And of course, it continues on. I just wanted to introduce you what a perfect square is.